Why did I choose this Athlon Ares 4.5-27x50 first focal plane for this Bergara HMR Wilderness 6.5 PRC multi-purpose hunting and long-range rifle? I'll answer that question in this video and tell you pretty much everything you need to know about this scope. Gavin here from UltimateReloader.com. Let me tell you about this rifle and this scope and why I ended up with this combination. This rifle is the Bergara B14 HMR Wilderness chambered in 6.5 PRC. This rifle has custom rifle performance. It's got the ballistic performance to take down big game of pretty much any kind you're going to find roaming around in North America, and the ballistics to go out well beyond 1,000 yards. So when I looked at what scope I was going to pair with this rifle, I was talking to Athlon and they said, hey, check out the Ares BTR GEN2 4.5-27x50. This is why I ended up with this scope, 4.5-27. 4.5 on the low end means I'm going to be able to hunt in densely wooded areas and not have too much magnification on the low end. 27 power gives me a little bit of extra headroom for testing and long range work. I like to have 6-24, something like that. This is even better because it's 4.5-27. It's got first focal plane, which is great when you need to have accurate holdover using the reticle at various magnification ranges, an important consideration for a hunting scope. And it's got exposed turrets for quick adjustments and more. What's really cool about the illuminated reticle is the fact that it's selectively illuminated. Only the center portion of the crosshairs, not the Christmas tree itself, are illuminated, and that means in low light situations like that early dawn shot or that late dusk shot, which I have taken before, killed a black bear almost at sundown, that's going to be a really, really useful attribute. So let's take the box and see what's inside here. I've not even looked at this scope yet, so you're seeing it with me for the very first time here. Had really good luck with the Athlon Midas tack scopes. Wow, that looks really nice. Yep, typical quality. I decided this time to go with MOA because I've been so heavy on mil. I think those MOA are a little underappreciated, and it kind of makes sense for me as a hunting scope. Look at that, batteries included for our illumination. We've got a dissectant packet here. We've got our cleaning cloth and our Allen key to set the zero stop. That's another feature that I really like about this scope. It's got the positive zero stop, which you can either use or not use depending on your scenario. It's got a 30mm tube. I've got a bubble level that's going to clamp on there from Lone Star. And so what I thought we'd do in this video is I'm going to get this mounted on the Bergara HMR Wilderness, and we're going to go through some of the tests that I've shown before, like a reticle alignment test, but I've got some new capabilities for testing things like the accuracy of the reticle hash marks and the accuracy of the tracking that I'm going to share with you, and much more. Here it is, the completed rifle. In fact, I've already published my overview of this Bergara B14 HMR Wilderness in 6.5 PRC. This thing shoots really well, sub-half MOA with factory hunting ammunition. You're going to want to check out that story as well. Continuing our story, covering the Athlon Ares 4.5-27 power scope, I want to talk briefly about mounting the scope. So first off, I've got Athlon precision rings. These are the low height. I start with the lower half of the ring. I push forward on it while tightening the clamp. Then check eye relief. If I feel like my rings are in the proper place on the Picatinny rail, I will then individually torque them down to 65 inch-pounds. Then it's a matter of dropping in the scope, dropping on the ring caps, and then using a kind of alternating cross pattern to get the torque established, this time at 18 inch-pounds. In the last video covering this rifle, I said foot-pounds. Whoops! That's an automotive term. This is definitely inch-pounds. I got the eye relief dialed in. You'll see here the sunshade and the objective have a nice strong 1/4 inch of gap. Anything less than that and I start to get a bit worried about the scope hitting the barrel or the handguard, depending on the type of rifle, under recoil. So you want your scope low, but not too low. I've already mentioned some of the specs, facts and figures, but let me run through the list from start to finish. Magnification range, 4.5 to 27. Objective diameter, 50 millimeters. Reticle, APLR3, first focal plane, MOA, also available in mil, glass etched, illuminated. This is HD quality glass with wideband, fully multi-coated optical elements. The tube material is 6061 aluminum and tube diameter is 30 millimeters. Eye relief is 3.9 inches and field of view at 100 yards is 22.7 to 3.8 feet. Turret click values are 1/4 MOA, 25 MOA per revolution of the turret with 80 MOA total elevation adjustment and 80 MOA total windage adjustment. Parallax adjustment is via side focus with a distance of 25 yards on the close side to infinity on the far side. The scope is purged with argon, has a length of 13.8 inches and a weight of 27.3 ounces. Here it is, folks. For a while here on the channel, I've been talking about some proprietary optics testing tools and equipment and processes that I've been working on, and this is kind of my first public display of these exciting new capabilities that I think are going to be a bit disruptive in the world of sporting optics. This is what I call the optics test rig, and this is not the final product. This is not even really a prototype. This is more like a mock-up. But what it does is it proves the concept that I had of this concept. What if you could take a look through the tube of an optic and do tracking tests at 100 yards? That's what this chart is right back here. This is the Ultimate Reloader 100-yard optics test chart for minute of angle 1.0. And what you can see here is 10 MOA up, 10 MOA down, left and right. And with this, there's even 1/4 MOA graduations here on the grid. We can see if the reticle graduations are accurate, those marks on the reticle for holdover. We can perform tracking tests. I'll show you the first iteration of that. That will show you how well does the scope track. Yes, we're going to still shoot and test tracking that way in these more extensive tests that are going to come, but you could do quite a bit of detailed evaluation of the tracking accuracy, repeatability, does it have backlash, and so on and so forth with these tests. But you need a way to see at 100 yards what your units are on a chart. That's the optics test chart. You need to have a fixture to digiscope, to look through the tube of the scope with a high quality camera. This is a Panasonic Lumix GH4, it's a 4K camera, and I'm using DSLR quality glass. This is not a phone we're using here. This is well beyond that in terms of optical quality and image quality characteristics. We can take a look through the tube. Right now I've got this optics test rig set up to look at the illuminated reticle. We have to have a setup where our camera is aligned perfectly, and when we're doing any of those tests, for instance at 100 yards, the tracking test, we need to have a setup where nothing moves. The platform doesn't move, the scope doesn't move, and the camera doesn't move. So it's not really feasible to do that type of testing with a rifle. You need a test fixture like this OTR optics testing rig. So let's do a quick demo here. I'm looking at the illuminated reticle through the scope here. I'm going to press record. So this is what the camera is seeing as if it were you looking through the tube of the scope. Everything has to be perfectly aligned. We need to set our eyepiece focus. We have to have the parallax set. We have to have the zoom appropriate. A lot of digiscoping specifics, and this is my first iteration at that. You can see how well that you can see things. If I turn on the illumination, I've got this pointed at my green screen. Right now we can see that. We can go through the different levels of lighting. I like that level right there. That's level number 5. We can change the power setting. You can see we're first focal here. So what that's going to do is change the magnification of the subject. That would be the target that we're shooting out, and it's also going to change the magnification of the reticle itself. If we had a second focal plane scope, obviously, the scale of the reticle would remain constant, but the holdover marks would only be accurate at a specified specific power setting. So let's go ahead and kill the house lights. Okay, now we can see just a little bit of illumination from my windows there on the green screen. But this gives an illustration of what are things going to look like closer to darkness. And some of that is studio lighting and some of that is light bleed from the window. But we can see here that when the reticle is illuminated, we don't have red light bleed from the illuminated reticle itself. It's nice and sharp. You can see here it's selective. I talked about the Christmas tree not being illuminated. This is the kind of capabilities, let's turn the house lights back on, that we're going to be able to get with this optics test rig and this whole new era of optics testing here on Ultimate Reloader. So I want to share some of the other results that I did from actual field testing with this setup. I took this exact setup up to the Ridgeline 100-yard range. I clamped it down to the new Ultimate Reloader concrete shooting bench. I've got a separate video on that if you're curious about how I put that together. Was very satisfied with how solid this setup was. What I want to show you next is my initial tracking testing. What I did here is I cycled through 10 MOA up and down and 10 MOA left and right. And you'll recall that's exactly the dimensions of this chart, accurate at exactly 100 yards. Let's see that test. All right, here we go. Up 10, 0, down 10, 0, 10 left, 0, 10 right, 0. What I learned when I ran that initial tracking test was I need a larger display, because when I reviewed the footage later, I saw what you probably just saw, which was I wasn't dialed exactly on the target when I started the tracking tests. But if you do look at the results, there was a certain offset. It was a little high, it was a little to the right, I think it was. That tracked steadily, and it looked like the tracking error was very, very, very minimal. So I give this scope a total thumbs up in the tracking category. The next test was reticle graduation accuracy. In other words, are the holdover hash marks accurate? And this test was a little bit interesting. What I noticed was in the elevation scale, everything was completely dead on, but on the windage scale on the right hand side, it looked like things were stretched ever so slightly, like the marks were too far to the right on the 10 MOA boundary there. And my suspicion is I might not have had the camera aligned just perfectly. If the camera was skewed to the left or to the right at all, there could have been a little bit of error, or those graduation marks could have been very slightly off. I'm not sure exactly what the situation was there. But overall, these graduation marks were dead on. When I was analyzing the images, the still frames from the video that came off the camera, I saw something really interesting, and that was the opportunity to evaluate a rifle optic for distortion. Now, if we think of camera lenses, especially at extreme wide angles, exhibit lens distortion. It's like barrel distortion. If you have a GoPro, you've probably seen that. It's a part of how the camera captures an ultra wide angle, and it's kind of by design in that particular case. With camera lenses or with rifle optics, sporting optics, you don't want distortion. And what I saw in those still frames was the fact that we had a perfect grid and we had the opportunity to draw rectangles to align this grid with a grid in post-production. And when I evaluated this particular Ares Riflescope for distortion, saw almost none. Very, very impressive. At the same time, I used to do what's called a plumb bob test for reticle alignment. You get the body of the scope perfectly aligned with gravity, in other words, level. You can use the top surface of the top turret or the bottom surface of the scope body, that flat area, to establish what's level. And as you look through the scope, the vertical reticle line should be parallel to the plumb bob that you're looking at over on a wall or in your scene, whatever that is. Now we don't have to do that because we've got the chart and we've got the reticle, and we can establish whether or not the vertical and horizontal reticle marks are parallel to the lines on the chart, the boxes, the grid essentially. And what I did to set this all up is I made sure that the scope was perfectly level with gravity, and then I also used a machinist level, this one right here that I use for the mock-up here, to make sure that the target was level as well. Now we have an inherent reticle alignment test built into the testing process, and it turned out things were spot on with level. A quick note about the through the tube shots that you just saw of this optics test chart at 100 yards. Please do not use these as a means to evaluate the optical quality of this scope. I will note that I did these shots early in the morning to avoid mirage. Don't want the heat boil distorting the image, obviously, while you're trying to look through the scope and see how accurately things track and so on and so forth. I had sunlight, the morning sun coming up, incident on the objective of the scope, and therefore things were a little bit washed out. On the topic of optics quality, that's an important part of the testing that I'm now evaluating methods for and evaluating controlled environments for. That'll be a topic that I will put off for a later date, but what I do want to show you is the effect of the power setting on light gathering and a very casual optical quality evaluation looking through the tube at a hillside at distance at various power magnifications. Let's look at that next. 4.5 power, 8, 10, 15, 20, 27. $27, 20, 15, 10, 8, 4.5. Here's the interesting thing about what I just showed you. When you look through a scope with the naked eye, like you normally would when you're shooting a rifle, as you increase the magnification, you might not even notice the decrease in light gathering as a function of that increased magnification because your eye does such a good job compensating. But with a DSLR camera with full manual settings, the acquisition of the image isn't being compensated for. It is staying absolutely static. So as we increase the magnification, we decrease light gathering, effective light gathering, and the image gets dimmer and dimmer and dimmer. So that's an interesting thing that we can compare as well, is how does light gathering change as a function of magnification? We're going to see this on all scopes. Field of view, there's a bunch of really interesting things that we can take a look at. For right now, I will leave you with looking through this scope. Things look really good. I think the test showed that things are really solid. This scope held its zero incredibly well, so I am really impressed with its performance. At the end of the day, I am extremely happy with this Athlon Ares 4.5-27x50 BTR GEN2 scope for this particular Bergara HMR wilderness rifle in 6.5 PRC. This is a dynamic duo of rifle and optic for the type of big game hunting that I do around here, and I love the fact that it has the partially illuminated reticle. That's going to be good for long range shooting. I have illuminated targets that are very difficult to get your crosshairs on at night, and if I am taking a dawn or dusk shot in a hunting scenario, that's going to be a great asset to have. I hope that you've enjoyed this kind of first look at advanced sporting optics testing. I showed you the mock-up of the OTR. I've got a lot more planned with that. I've got parts for the real OTR here in the shop, and I'm going to be looking at different test scenarios and different test methodologies. So if you have a question or a comment about Athlon optics, including this Ares Riflescope, please drop a comment and we'll start a discussion. If you have feedback or things specifically that you'd like to see in my future optics testing, please drop a comment and we'll start a discussion. I really appreciate the fact that you've taken the time to take a look at this video. If you liked it, please give it a thumbs up. Don't forget, I've got a full article. I've got Ultimate Reloader shirts at the Ultimate Reloader store. I'm on Patreon. Links in the video description. Make sure you're subscribed with notifications because I have more content covering this rifle and scope duo. I've got more Athlon gear here in the shop that I'm going to take an in-depth look at. You're not going to want to miss any of that. Thank you for watching. Until next time, happy shooting and happy reloading.